So yeah, so these are some of the situations. Okay, so for example, there can be a division by zero error. Okay, or there can be a let's say an exception caused by let's say some sort of a system interrupt. Okay, so for example, somebody may just press Control C and that may be propagated to your signal. Okay, so your signal may to your program. Okay, and your program may be asked to stop abruptly. Okay. Or it could be some other external exception, like it could be, for example, that you have run out of memory, so your malloc is not able to allocate any more memory. Okay, malloc or new, whatever. Okay, or it could be so this that could be an exception. Okay, so then there are exceptions which can be which can be caused by the way you are processing. So for example, for some reason, so let's say you are having this stack object, right? So we have all seen the stack program. Okay, and when the stack is empty, your stack top should be -1. Otherwise, it should be between, let's say, 0 to size of the stack, right? So this is how you do the stack. Okay, but suppose your stack top, for some reason, for some corruption or something, happens to be -3 or -4. Okay, so that is an exception condition. Okay, so all these kind of conditions can arise when your program is running. Okay, so what happens when these exception conditions arise, right? So what happens is that your program, which is designed for a particular functionality, okay, is no longer able to achieve that functionality. So it cripples the program, okay, and in some cases it may also pull the entire system down. Okay. Um, so all these things can happen. Okay, so this is these are what are called the exception situations. Okay, or exception conditions in your program. Okay. Now, obviously, yeah, so we just discussed some of these causes for exception, right? So it can be your memory is less, disk space is less, and so on and so forth. Okay, so there can be, you can see that all these errors are possible. Okay, so unexpected system state, external events, logical errors, runtime errors, undefined operation, all these things are possible. Okay, so of course, we need to, or a good program should be able to handle these exception situations. Okay, at least somehow it should be able to handle the exception situations. Okay. Um, Now, so the question is, so this, this the programmer should do. Okay. Now, the simplest thing that can happen is basically that you can at least report that an exception situation has happened. Okay. Okay. So in other cases, you may you may do something else. Okay. So there should be some code or some function. Okay. Which should take care of this exceptional flow. So basically, now you can think of your program, execution of program, as a flow. Flow in the sense that the control is flowing from one statement to another statement. So it's like a path through the statements. Okay, that you have written. Okay. Now, what we are seeing, so what we can think at the time of writing the program is that you can have two flows. Okay, one is this normal flow. Okay, so what is the normal flow? Normal flow is that no exception condition has happened. Okay, and your program can actually perform its intended task. Okay, and there can be this exceptional flow. Okay, so exceptional flow means at least one exception condition has happened, and as a result of which your function, at least if nothing is done, okay, cannot perform its usual its intended task. Okay. Okay, and so yeah, so now exception handling, basically your sort of your objective will be to take once an exceptional flow condition has happened, the exception handler should bring the program, at least if possible. In all cases it may not be possible. If it is possible, it should try to bring it back to normal flow. Okay, so so this is the thing, and if nothing is possible, then it should try to do error reporting. Okay, so now so this is about exception handling. Okay, now so the language, like we have seen the C programming language, we have seen the C++ programming language. Okay, so in C programming language, there is no special mechanism to handle this exception flow. Okay, so according to yeah, and whereas C++ has a special mechanism which are called exception mechanisms, which are used to which are it's a language feature which is designed towards handling this exception. Okay, and so according to Stroustrup, exceptions are a means of separating error reporting from error handling. Okay, so we will see what this means. Okay. Okay, so now again there can be various types of exceptions. So there can be asynchronous exceptions, so exceptions that are not not in the programmer's control, or at least it happens because of some external event like an interrupt or something that happened. Okay, and there can be synchronous exceptions, something like division by zero or something, which are in some sense things which you expect that they will happen in some for some program state. Okay, so for example, if you are dividing, you are doing A by B, you know that if B is 0, then it will throw a division by 0 error. Okay, so division by 0 exception. Okay, so you sort of can control, you can catch that and continue. Okay, so so these are the two types of exception. Okay, now exception. Yes.
Sir, please go back to the previous slide once. Sir, can we call asynchronous exception as unhandled?
No, you have to handle, I mean, the more number of exceptions you can handle, the better your program is. So no, it is not unhandled. I will come to that. Okay, we'll come to that. Just we'll come to how you catch exceptions, all types of exceptions. Okay, now these are the stages of exception. Okay, so the first stage is error incidence. So the exception should actually occur. Okay, so the error condition has occurred. Okay, then the second stage is that you create an object and raise the exception. Okay. Then the next step is to detect the exception. Okay. That somewhere there should be some code which should be detecting the exception. Okay. Then the fourth stage is to handle the exception. So so this may come to your the last question that was asked, that how can you handle an exception. Okay, so if you don't know what to do, okay, then you can simply ignore the exception. So in that case, your exception is not handled, and your if your program ever encounters that particular exception condition, it will just crash, it will fail. Okay, so nothing can be done there. Okay, you can try to act, of course. Yeah, so you can you don't know, so you cannot completely handle the exception right now, but you may collect some you may collect some information, or you may do something, okay, some calculation, okay, and then rethrow the exception for something downstream to be handled. Okay, or you can completely handle the exception. So nothing to be done there, nothing to be done downstream from there. Okay, we'll see all this with an exception. Okay, yeah, so and then you can so finally you can there can be some sort of a recovery from exception. So if the recovery is if the exception is handled inside the program, then you continue execution, otherwise you abort the execution. Okay, so so these are the 5 stages of exception. Okay, so so here basically you can see, so so let's say so this is the function which is executing, and let's say if this error variable is 0, then the error has occurred. Okay, so so the first thing is yeah, so this is the stage 1 where error actually occurred. Okay, now as the error occurred, okay, you basically generate an exception object. So in this case, it's a very naive exception object, which is that you just return a preset value, which is -1. Okay, so it's a very naive way of handling generating an exception object. Okay, now this function is called here. Okay, and here let's say you are expecting the output of it to be 0. Okay, but now that it has got a -1 out, okay, you have detected this exception. Okay, and then after detection, this is where the exception handling code will sort of go in. So the exception has to be handled. Okay, and after the exception has been handled, your program execution can it can recover. So if it's handled, it will recover, otherwise it will abort. Okay. Okay, so so let us just briefly look at what are the ways that exceptions are handled in C. Okay, so we will go over this very briefly. Okay, since most of you know. Okay, so the first thing can be function return value mechanism. Okay, so yeah, so okay, so yeah, okay, so okay, so so for example, let us look at this mechanism with this example. Okay, so what happens here? Basically, what what you do, let's say you have a push function in a stack. Okay, and now let's say so int I is your input here. Okay, normally your push function will just be a void function, right? It should not return anything. Okay, so and then this is the push code that you basically, if the stack is not full, then you simply push the thing. Okay, so if this is the case, okay, then you return 1. Okay, which means that the push has been successful. Okay, if the stack is full, you return 0. Okay, so then in the main, you can just say if not push X, then you do something, some sort of exception handling. So this is the most common mechanism that a C programmer kind of uses. You can think of it like this. Okay, so this is so you add either a return value or a return parameter returned by pointer or something like that, in order to return one extra piece of information, which basically tells whether an exception has happened or not. Okay, so this is one way. Okay. Now there can be the local go-to mechanism also. Basically, what you can do, you can have. So let us see here. Okay, so you can have all these. So this is taken from some library code. Okay, so essentially, this sig retalk is one exception condition. Okay, sig ret error is another exception condition, and so on and so forth. Okay, so what you can do, you can basically, so whenever an exception happens, okay, you can just, so if you have a large function, okay, you can simply go to this particular, so whenever you detect a particular exception condition, you can directly jump to this particular exception handler. So, again, a very crude way of handling the exception. Advantage is that what we will see is that basically the exception handling code is clearly separated from the actual normal flow. So this initial portion is normal flow. Okay. If there is an exception condition, then you enter one of these exception codes. Okay. But yeah, but there is no, so the mechanism is not proper. Okay. So, and then there is no robust way of, also, I mean, again, you have to, so everything is basically left to the programmer. Okay, so if, let's say, now this, how the exception is handled, again, needs to be thought through and designed by the programmer, so that, if suppose the exception is not handled in this particular case, but it needs to be passed on to a calling function or something, that mechanism should again be set up. Okay, so so these are the problem. Okay. Yeah, so this is the sort of the illustration of running of that particular mechanism. Okay. Another sort of mechanism is this global variables mechanism, again used very much in C++. So for example, there is this header file called errno.h. Okay. So what happens is that, suppose, you are sort of calling this function, let's say math function. Okay. And, let's say x to the power y you want to calculate, and maybe, x is a negative number and y is like a fractional power or something. So the result is undefined, right? So there is no result. Okay. So in that case, maybe, so what happens is the power function, it returns a garbage value here in result. Okay. But what happens is it sets this global sort of variable, which is this ERRNO. Okay. And then after this function has been called, you can simply check this ERRNO variable to see if there is a, if there is some exception has happened or not. Okay. Again, as you can understand, this is highly error prone, because so one very common error is that when it depends on when you check, right? So it may be that the error actually occurred here, but there was some there was an error occurring here, and then there were some intermediate statements in between here, which also caused another error. So basically, this old error will be lost, and that leads to a lot of bug. Okay, so yeah, so a very common bug here is if you try to print something here and the print statement causes an exception, then causes the ERRNO to change, then you don't get the original ERRNO value anymore. Okay. Okay, so so these are some of the conditions. Okay, so yeah, so another thing is that you can use yeah, so another problem is with exceptions is that many a times what happens is your program has a crash or a catastrophic failure, okay? And that can lead to the entire system being crashing. So the rest of the system had nothing to do. So for example, I'll give you an example. So suppose you are, inside your program, you are accessing some database handle or something, and your program crashed, okay? But the database program is running fine, okay? Or let's say you opened some file handle, okay, and then your program crashed, okay. So your file will that particular file will remain open in the operating system, okay. But that shouldn't be the case because the operating system did not crash, okay. So that is the problem, okay. So for solving this kind of a problem, again in C there is this at exit kind of mechanism, again at a very high level, okay, that you can set handlers in reverse order of their registration. So here is an example. So if you have this program, let's say, okay, and so this exit is basically the exception condition. Let's say this is where so when you call exit, it basically your program basically exits, okay. So if this is the case, then what you can do is you can say that you can have functions like at exit handler 1, at exit handler 2, and all. These are void functions basically. Yeah, so these have to be void functions, but these will perform a certain computation if you exit your program normally, that is either using exit or even otherwise, if you just if you just return, then also it's a normal exit, okay. And in that case, what you can do is you can sort of release the file handles or something like that. So you can release all open file handles or something like that, okay. So this is another way of handling exceptions in C, okay. Yeah, okay. So okay, so this is one, okay. And then there is the assert, assert functionality. So it basically says that basically you have this assert function where if you you put an expression there, if that expression is true, okay, or rather if it is false, then there is an abrupt termination of the program, and followed by there is some information is printed about the condition which failed, okay. So these are some of the ways in which in C you can handle exceptions. But as you see, so there are 2-3 things you should see about these particular methods of handling the exceptions. First of all, they were sort of added as an afterthought. So they are not the language features, but there are some library features or some system features which are added as an afterthought, okay. So no coherent way of handling exceptions, okay. Secondly, they kind of provide, I mean, they leave too much to the developer or to the programmer, okay. So so the programmer has to take care of everything, and the system, there's no one single uniform nice system to handle exceptions, okay. Okay, so how do we how does C++ exceptions, how does it help, okay. So okay, so so what are the so first of all we must ask that, suppose we are providing a language feature for handling exceptions, then what should this language feature look like? Okay, so what are the expectations from this language feature? Okay, so these are some of the expectations. Okay, so first of all, separate error handling code from ordinary code. Okay, so it should be, in such a manner that all the error handling code should be separate from the normal flow, so that it is very easy to first write the normal flow, and then you add the error handling code. And also, if somebody is reading your program later on, they can also easily find that this is the normal flow and this is the exception condition. Okay, so this is one thing. Okay, it should be a language mechanism rather than a library. Okay, yeah. So the another important thing is, C++ has this idea of so it's an object-oriented system. So there are these different ways of creating objects, like different constructors, and also different ways of destroying objects. And you have already seen that whenever you define a class, okay, you sort of, if you define it well, it should be a self-contained sort of a piece of code, or you can say a self-contained class definition, which basically takes care of all these kind of different side effects that your exceptions may occur. So, for example, it can, if some memory has been allocated, okay, that memory should be freed if the exception condition occurs. Okay, and that's taken care of by the destructor. So even if the exception condition occurs, maybe the destructor should be called for some of the variables which are created inside that particular try block. So we'll see, okay, or inside that particular function, for example. Okay. Yeah, so basically the automatic variables should be taken care of. Okay, so this is the other thing. Okay, and yeah, so destructor should be called. Okay, then there should be less overhead for the designer. So the designer should not have to, by designer we mean the program designer or the software designer. Okay, the software designer should not have to take care of passing the exception to all the levels. All that mechanism should be kind of intuitive and automatic. Okay. Yeah, so exception propagation from the deepest level should happen. Okay, and also various exceptions should be handled by a single handler. So again, it should not be that at different places the coder is writing different handler code for handling different exceptions. Okay, so another way of thinking about it can be that so you can handle certain exceptions that you foresee specially, okay, but there should be an overall catch-all exception handler also. Okay, so we will see how all this is taken care of. Okay, so how are exceptions handled in C++? Okay, so there are three main features which are used for handling exceptions. Okay, so the first one is try, the second one is throw, and the third one is catch. Okay, so what is try? So try is a block of code, here you can see, okay, which will be monitored for exceptions. Okay, so this is what is try. Okay, what is throw? So throw is basically a mechanism by which C++ allows the programmer to throw exceptions. Okay, so to create exception objects and then throw them. Okay, and catch is basically a handler block. Okay, so catch allows you to specify a handler block. Okay, so this is what these are the three things which together constitute exception handling in C++. Okay. So for example, in this case, you can see that this particular code is monitored, okay, for exceptions. Okay. So if there is no exception, then G will be called and G successfully returns. And then so suppose this throw is not there. Okay. So then G will successfully return, and then this catch block will never be called. Okay. But if this throw is called, okay, what should happen? So so once G is called and the function G, some calculation inside function G throws an exception, okay, then what should happen is this exception should be caught, okay, and then then the catch block should be executed. But before the catch block is executed, the stack frame of G should be unwinded. Okay, so which means that, for example, you have created this automatic variable A here. So this this should be destroyed. Okay, and suppose you had created some kind of some kind of object, then the destructor will be called, and so on and so forth. So this should happen. Okay. Okay, and then remaining execution of G should be skipped. Of course, the call to H will be skipped because the exception has happened inside G. Okay, and your control will come to this catch block. Okay, and then this catch block will be executed. Okay, after the catch block has been executed, again here the normal flow will resume. So your program will not crash unless you throw inside the catch block also, you don't handle it, but you throw another exception. Okay. So for example, in this case, you are handling in the sense that you are simply doing error reporting. So you are printing the exception. Okay, ex.what. Okay. So in this case, the normal execution will continue. Okay.
Sir.
Yes.
Sir, user USR EXCP, sir, what is that class? Sir, why we are making an object of that class?
I'll come to that. I'll come to that. Don't worry. Huh? Don't worry. Huh? So I'll come to that. So now you see, okay. So what you so the question is, what do you throw? Okay. So so in this particular case, what we have done is we have defined this class called user exception. Okay, and we have derived it from this exception class. Okay, and we are throwing an object of an exception class. Okay, so for the time being, think of it as any object can be thrown. Okay, but it is a good programming practice to actually throw exception type objects. Okay, and what are exception type objects? So typically, so the question must come that when you are throwing an so you can also throw no object. Okay, so here you are throwing this ex object. You could have also not thrown any object here, just the exception. So you can just say throw. Okay, and you can catch all. Okay, and then that is also one way to do. Okay, but if you throw an object, you have to understand that what is the purpose of throwing an object. The purpose of throwing this object is that you want to collect some information about the exception. Okay, and we will see that how you can collect some information about the exception. Okay, like so there is this exception object which has some predefined exception class which has some predefined function, and you can also you can inherit from that class, and you can you can construct your own exception objects for handling particular exception situations. Okay. Okay, so we will come to this. Okay. Yeah, any
Sir,
question?
so this, yes, sir. So user EXCP is a predefined class.
User EXCP is not a predefined class. It's a class that you are defining here, right?
So, sir, there is no function what, no, sir, in the definition.
Yes, it is there in the exception class definition. So you are just
Okay. Yes, sir. Got it, sir.
okay. So
Yes, sir.
okay, we'll come to this. Okay, so don't worry about this. Okay, okay. So now the next question is, how does how does the catch block work? So we understood how the try block works, right? Try block, basically whatever happens inside the try block will be monitored for exception. Okay, now once the, remember, so that once the exception happens, we have to actually detect it, or we have to catch it, like, that's the catch statement. Okay, so how does this catch work? Okay, so the catch basically works by it's similar to a function call. Okay, but so it works using the type of the object which is thrown. Okay, so here is an example to illustrate that. Okay, so inside this G function here, okay, we are calling this H function. Okay, and H function has various ways of throwing exception. So it can throw an integer. Okay, it can throw a floating point number. Okay, it can throw this my exception class. It can throw the predefined exception class. Okay, which is here. Okay, and it can throw my class, which is not inheriting from the exception class. So it's just a, it's just a object of my class. Okay, so all these can be thrown. Okay, so now you can have various catch clauses here. Okay, so you can so the first one will catch the int. Okay, so this will catch line 1. Okay, and it is doing whatever it is doing. Okay, so the second one, so notice that one try block can have multiple catch blocks. Okay, so it's not like there has to be only one catch block for a try block. Okay, so the second catch block is catching double. Okay, and the third catch block here is a catch all block. Okay, so it is catching, you see, inside catch you have 3 dots. Okay, so this basically, this catch block will or this catch statement rather will capture all the catches. Okay, sorry, all the exceptions. Okay, so another way of thinking about it is, if the exception thrown is of type int, okay, it will match this catch statement. If the exception thrown is of type double, then it will match this catch statement. Okay, and this catch statement will match no matter what exception you throw. Okay, whatever is the type of the exception. Okay, so this is how the catch statement works. Okay, yeah. Now,
Sir, but why doesn't it catch exception from line 1 and 2?
why doesn't it catch means, why doesn't this particular catch statement catch exception from line 1 and 2?
Yes, sir.
Yeah. So now we come to the the second portion, that these catch blocks are matched with the thrown exception one after the other. Okay, so the order in which you specify the catch blocks, okay, is important. Okay, so for example, so here is a very simple example. So suppose you place this catch all block on top of all the other catch blocks. Okay, what will happen?
It
Can
will
some,
only execute the triple dot catch.
yes, so all exceptions will be caught using this throw. So these pieces of code will never be executed. So this particular piece of code or this particular piece of code will never be executed. Always the code inside this catch block will be executed. Okay. So always when you are providing the catch blocks, you provide the most specific catch block first. Okay, so the most specific exception that you want to catch, okay, you should provide the handler for that first. So another way of, another statement for this thing is that this is the handler for int type exception. Okay. Yeah. So basically, most specific type of exception should be handled first, and then the most generic type of exceptions should be handled. Okay, so this is one thing. Okay, and we'll come to what is generic, what is specific here. Okay, but one other important thing to understand here is that there is no so while matching this, okay, so you are throwing something, right? So you are throwing an exception, an expression here, right? An expression can be some object, or it can be like, it has to be some object, right? Something of some type. Okay. While matching the type to the object, there is no implicit conversion. Okay. So for example, if you don't provide this int block, okay, and let's say you throw an integer exception here, this will not be implicitly converted to double and matched here. Okay, so that implicit conversion will not happen. Clear? Okay, so now this is one thing. Okay, however, one type of implicit conversion happens while matching this catch block. Okay, and that is upcasting on a type hierarchy. Okay, so for example, so let us look at this example. Okay, so now you have created two type. You have the exception object, which is already predefined in this exception library, in this exception header. Okay, and you have created also my exception object, which is derived from this one. Okay, now you see. So here what you are doing in this G function, you are all other types of exception you are catching, and then you are rethrowing this. Okay, so this is called rethrowing. You can simply catch all. You don't even know what you have caught. Whatever you have caught, you are just throwing again. Okay, so that is passed down to the the calling function, or the next calling block basically to handle. Okay. So now you see here. So now here we are trying to catch this my exception and exception. Okay. So now you see this one catches line 3. Okay, this my exception. This one catches line 4. Okay. Now, if this my exception was not there, okay, so if this catch block was not there, this will catch both line 3 and line 4. Okay, because this my exception type can be upcasted to exception type while doing the type matching in the catch phrase. Clear? So this is another feature, and basically what this allows you, it allows you to create an exception hierarchy. Okay, so you at the top of the exception hierarchy is the predefined exception class. Okay, now you can create all these new types of exceptions. So let's say you can create various new types of exception, like like maybe numerical error exception, memory out of bounds exception, all these kind of exceptions you can create. Okay, and if let's say so what you can do now, let's say you know, all so inside exception, or you know, below exception, you first create something like all numerical exception class, okay, which is basically you know, which is a super class for all exceptions related to numerical computation. So this could be divide by zero. This could be overflow, like your you know, your the number you are generating is too large. Okay, this could be something like domain error, like something like you are taking a square root of negative number. Okay, all these kind of exceptions will come under numerical exception, let's say. Okay, so what you can do, you can have a single catch statement for numerical exceptions. Okay, and then you can handle them all together. So this is possible because of this particular feature. Okay, I hope this is clear. Okay.
Sir,
Yes.
sir, when we return a double value, can't it be cast to typecasted to an integer? So it may end up in catch int block.
No, that is what I'm saying. So all implicit conversions are not done in catch. Clear? Is this
Sir,
clear?
but
Yes.
upcast is allowed.
No, yeah, so that is what I'm saying. It's a special feature that is upcast. So for, yeah, so upcasting on a hierarchy, on a type hierarchy, is a special feature of this matching. Okay, but all the other types of casts are not allowed. So it's either an exact match or an upcast on a hierarchy. These are the only two things that are allowed. By allowed, I mean they match. So here there is no allow or disallow, right? So the matching logic works like this. Okay, so whenever you are matching an exception to a catch statement, the matching logic is the following. If it is an exact match, the type is an exact match, that is the first priority. Otherwise, if it is an upcast on a hierarchy, it's not otherwise actually. So it's either an exact match or a upcast. So it's not really an if and only if condition. I mean, it's like the two cannot happen together. Okay. So these are the only things that are allowed. Okay. Otherwise, it's a catch-all. So catch-all catches, of course, all types. Okay. So this is a special phrase which catches all types. I hope this is clear. Okay. So yeah, so this we have discussed. So basically, the try block is the, you know, consolidate the areas that might throw exceptions. You can also have function try block. So the entire function can be under try block. So you can just directly do like this. Okay. And your try blocks can also be nested. Okay, so you can have a try block inside a try block. Okay. Yeah. So yeah, so this is the try block. Okay. Yeah. So yeah. Yeah. So catch block is basically you know, it provides the name for the exception handler. Catching an exception is like invoking a function. Okay, it immediately follows the try block. It has a unique formal parameter. So catch like the catch phrase has a single formal parameter. Okay. Okay. Yeah. And yeah, it can also be simply just a type name, like we discussed. So if you don't want you know, to get the object, that is also fine. You just get a type name, and then it will just match that particular type name. Okay. So let me see. There will be some example there. Okay. Yeah. So this we have discussed. So exact match, generalization, specialization. The other type of matching is pointer types. Okay. Yeah. Yeah, so basically pointer types can be matched by standard conversion. Okay, so this is yeah. These are the only three ways of matching exception type to a catch block. Okay. Okay. Yeah, so here you can see that there's this exception object that is created here, and this so it matches you know it matches the what do you call this reference to that particular type. So in this particular case, you are taking a reference. So basically, a reference to this particular exception object is passed here. Okay. Similarly, for pointers also. Okay. So you can catch something like a reference or a pointer. Okay, which is like standard pointer conversion or reference conversion. Okay, or you match only the objects. Okay, I think this is clear. Okay, now yeah, so and the matching happens in order of appearance. Okay, this we have seen. Okay, so this we have discussed already. If base class catch block precedes a derived class catch block, then basically there is unreachable code. Okay, and as a result, this catch all block should be the last one. Otherwise, again, there will be unreachable handlers. Okay. If no matching handler is found in the current scope, then the search continues. So suppose there is an exception which is thrown inside a try block, okay, and there is no matching handler. Then basically what happens is it keeps on searching in the other enclosing block. So let's say this is a function call that happened inside a function call that happened inside a function call. So like for example, in this particular case. Okay, so in this case, actually, we did a catch-all and throw. But if we didn't do, then it will also try to match this H thing inside, this F, because this exception happened inside the H block, which was inside the G, which was here. Okay, so basically this will continue. Okay, sorry, here it will not, because yeah. So sorry. So here it will not, because this is not inside this particular block. Okay, yeah. So yeah, so matching will continue if it's basically if it's a nested try block, it will continue in the so in the dynamically surrounding try block. Okay. And in this case, the stack unwinds, okay, of the previous block. Okay. And eventually, if no handler is found, then abnormal termination is done using the terminate method. Okay. 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 So next, okay, are we out of time now? Okay. Okay. So let us discuss the details of throw and everything in the next class. Okay. Let us continue from here in the next class. Any questions or comments till now?
Sir.
Yes.
In the example where one function was calling the other, like F was calling G and G was calling H. Suppose we throw something which cannot be, like from H we throw something which cannot be caught by anything in G. Then will it terminate, or will it now check the catch blocks in F?
It will terminate.
Okay, so for a given call, it will check only for the catch blocks in the current try block and nested try blocks.
Yes. So actually, it will check in in the not just trie block. Yeah, so you can say, yeah, so you can say that's any dynamically surrounding trie block. Yes, so it will only check in those.
Okay, sir. Okay.
Yeah.
Sir, it means like if it cannot find in G, then will it check in F's trie block?
So in order to make it check in F, you use this particular thing. Okay, so you do a catch-all and then throw. Then, like I said here, it will check. Okay, but if you don't have this catch-all and then throw, then it will not check.
Okay, sir.
Okay. Any other question? Okay then. Thank you everyone. So we meet for the lab class.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.